CATIA V5. This will be regarding cable joint. So this will be the case study part. Let's quickly analyze this. We have the large component over here in the middle in orange. This will be the support, and we're going to have cube 1. In this case, the naming for the second one will be cube 2, even though we're going to see that this will have a rectangular shape. This will be a perfect cube, and if I will measure the distance, this will have the 20 millimeter length. Now, regarding cable joint, if I will double click over here on cable joint, we're going to see that actually a cable joint will be composed of two prismatic joints. And in this case, we can either define the prismatic joint with the face over here on the support and the underlying surface of this cube, or we can go with an edge. So the edge over here will be coincident with the edge for the cube, and the same over here. If I will move my mouse over here, we're going to see that in this case, the length driven is set for prismatic 1, which is the first joint over here. And afterwards, the second one will not be length driven. That will be conducted by the cable joint. If I'm going to play the simulation now, so I'll go over here, simulate mechanism. I will go all the way to 100. We're going to see that the top cube will travel all the way to the end over here. If I will have that animation replay, we're going to see how it will travel. And we're going to see the one that will slide over here on the vertical axis, will extend and go over here. Currently, they will travel the same distance. So if the one on the top will travel 100 millimeters from the starting point, if I go again to 0, this is the starting point. And from here all the way to the end will be 100 millimeters. And the same distance will be traveled by the one over here as well. We can change that ratio. If I'm going to double click on the cable joint, we're going to see that we have a ratio over here. So if I will go over here with a ratio of 0.4 in this case, I will simulate the mechanism again. And I want the cube on the top to travel 100 millimeters, just like before. So I'm going to add the value over there. And I'm going to see that the second element over here will travel all the way to the bottom over here. So this is the ratio of 0.4. That means that the bottom one over here will only travel at 40% of the distance from the one on the top. And this is how we can easily adjust the cable joint simulation to our needs. And we can control that using the ratio. So overall, cable joint is quite a simple mechanism. In order to define it, you actually need to define two prismatic joints. And afterwards, you can select which will be the length driven. If it will be the one on the top in this case, so prismatic 1, or the other one. So you can have both of those to be length driven. This is very useful in various applications, especially if you're going to make this and have it transferred to DMU, for example. And over there with cable joint, you can simulate a wide variety of case studies. Okay, so I hope you enjoy this kind of content. I will position a similar video over here on the left and the subscribe button to the right. So that's it. Thanks for watching.